Are we trying to send someone here? She can take a photo of it.
You can turn it into OneNote, it's fine.
That's good.
Dr. Blue, can you
All right. So, new type of problem. You were asked to solve for theta if sine theta is equal to negative 0.32, and we're looking between pi over 2 and 3 pi over 2 for our answer. Notice the directions here are virtually identical as the previous type of problem, right? What's the difference you see? I see a decimal, right? That's going to tell me that I'm not going to be using my unit circle to do this problem because there's no decimals on my unit circle. Okay? So that's my Q. All right. So I'm going to start the exact same way. I'm going to observe that here sine theta is negative because it's equal to negative 0.32. Give myself a little bit more space. In what quadrants is sine negative?
S and C.
T and C. A for all of positive, so sine's positive there. That's not what we want. S for sine positive, not what we want. We want the bottom two, T and C. Okay. Then let's look at that piece from pi over 2 to 3 pi over 2. So 0, and I'm going counterclockwise because they're positive angles. So we covered from pi over 2 to 3 pi over 2 happened between quadrants 2 and 3. X.
Wait, so you said you can because you can do like 0, 0.5.
Sure.
You can do that.
Yeah,
Alright.
that's fine.
But if you do that, I forgot how do you if it's with the pi, so is pi just 1?
Yeah, 1 pi. Right, because there's a 1 in front of the pi, we just don't write it.
Yeah.
Is that okay?
Yeah.
Okay. We'll get there in a second. You're just a little quick on the draw for me, but we'll get there. So what this is saying then is our answer, the terminal side of our answer lies somewhere in quadrant 3. Is everybody okay with that idea? Now, what I'm going to do is I'm going to break. Oh, let's give me that back still. So this is like my theta, that's my answer. I'm going to break that theta, though, into 2 parts. Okay? Because my calculator is not going to spit this angle out for me directly, because if you remember, back to the first lesson, the range for sine inverse is negative pi over 2 to positive pi over 2. So it can't give me an answer in the 3rd quadrant. Is everybody okay with that? So what I'm going to do is I'm going to break up this into 2 parts. I'm going to break it up into that part. That's a terrible color. Yellow maybe? Yellow maybe? Thank you. And this part. This angle here is called a reference angle. That reference angle is always made between the x-axis and the terminal side of your solution. We repeat that because it's important. The reference angle is always drawn between the x-axis and the terminal side of your solution. Okay? Never y. So far, so good? So I'm going to name that reference angle. I'm going to give it a name. I'm going to call it alpha. That's like just the Jesus fish symbol. Go ahead. Okay, so I'm going to use that symbol to represent alpha, or I represent my reference angle. So I know theta is the purple part plus the yellow part. Everybody agree? If we just look at it common sense. What is that angle that the purple angle is? How much is that angle? 180 degrees. But if we're doing this in radians, it would be pi, right? We go from 0 to pi. And then the yellow angle we called alpha. Everybody's okay? Yes.
Is like the orange angle, is that point that you like sine minus?
No. No. It's going to be pi plus alpha. We have to talk about how to find alpha. That's our final term. Okay? Are you still on board? So we're good. All we don't know how to do yet is find alpha. As soon as we find or figure out how to find alpha, we just add pi to it, boom, we have our answer. Agreed? Okay. This is how we find alpha every single time. Alpha is going to be sine inverse of the absolute value, in this case, negative 0.32. Why am I using sine inverse? Because there's a sine equation. Yep. If it was a tan equation, would I do tan inverse? Yup. If it was a cosine equation, I'd do cosine inverse? Yup. If it was a cosecant equation, I'd rewrite it as 1 over sine, flip it, and then do a sine inverse, just like we did before. So all that stays. So now it's calculator time. That's what I want. So I'm going to type into my calculator pi plus sine inverse. So second, and then the sine button, which is kind of above the number 7. And now I can type an absolute value into my calculator, but it's like such a waste of button pushing. Can't we just do the absolute value of negative 0.32 in our head?
Yes.
What is the absolute value of negative 0.32?
0.32.
Positive 0.32. That's the way I'm going to do it. I'm never going to type it into the calculator. I'm just going to do it in my head because, Mr. Kulik, I can drop negative signs even though I don't need to drop negative signs. I'm really good at that. That was supposed to be a joke. You know, like, haha. Okay. So I do that, and then I press enter. So my answer, I would write on my paper, if the directions say rounded 2 decimal places, would be 3.47. Did anybody following along with me not get that number? You got like 20 something or yeah, right? Okay, so the issue is the mode of your calculator needs to be in radian mode as opposed to degree. So we press the mode button right next to the blue second, scroll down to where it says radian, press enter to make sure radian is selected. If you redo that same thing now, you should get the same 3.47. Did it work? Excellent. Okay, come back. That's our answer. Now, before we move on to the next problem, we should check our answer, right? That's a good idea. These are all eminently checkable. The check is two parts. The first part is, new color. I want to check to see that 3.47 is between pi over 2 and 3 pi over 2. Well, I don't know what, those are pi's and that's a decimal. I'm just going to go to my calculator, type in pi over 2 and 3 pi over 2 and see what I get. So pi over 2 is 1.57. 3 pi over 2 is 4.71. So we're good there. Because 3.47 is in between. That's part one of my check. So far, so good?
Yeah.
Part two of my check is going to be to make sure that sine of 3.47 gives me negative 3.2. So I'm going to go back to my calculator, and I'm going to do sine of my answer. So I'm going to just copy in the whole answer, and I'm expecting to get negative 0.32. Is that close enough for you guys? Good enough for me also. So what does that tell me?
You're right.
I am 100% sure that I have the correct answer. Can I always do that check? Yup. Should you always do that check? Yup.
So in the beginning of it, why do you add pi like to the graph? Like trying like why do you add like the y like on it?
Because if I do sine inverse, the range of values for sine inverse that the calculator is going to output are only between negative pi over 2 and positive pi over 2. It can't give me an answer in the third quadrant, or an answer that's bigger than pi over 2, or an answer less than pi over 2, or I'm sorry, less than negative pi over 2. So I have to do it this way because the calculator just can't output it.
So like if we had like other values like cosine, would you just add or subtract one like 180 to each side?
Well, the amount you add or subtract depends on the picture you draw. So it depends on where your answer is living. Let's look at the next example, and then we'll try to consolidate this into a rule that can tell us how to write that equation for theta, because that's the trickiest part of this. Jacob.
You know the equation for like where's pi plus alpha, like is the pi gonna like is it always gonna be pi?
No, that's what Alex was just asking.
Yeah,
Yeah, so this, writing this equation is the trickiest part. We'll make that easier in a second, but I want to do one more to show you guys, get a feel for what's going on. And then we'll try to like build out a way to do this. Deal? All right. All right, our next problem, cosine theta equals 0.32 from 1 pi to 2 pi. So again, start the same way we have. What quadrants is cosine positive in? 1 and 4. Everybody agree? In A and C? The next piece that we're going to do is from the quadrants covered by 0 to 2 pi. So again, I'm going counterclockwise because these are positive values. So from pi to 2 pi was quadrants 3 and 4. So that's what my solution's going to look like.
Draw that line in the circle exactly exact, it's like.
As long as it's the terminal side is in the correct quadrant, you're okay. That's as good as we're going to be able to do with the information that we have available to us right at this second. So, where is my reference angle going to be? Where is the reference angle here? It's always between the terminal side and the x-axis. Oops. So my reference angle is there. Always between the terminal side and the positive x-axis. It has to be an acute angle as well. I guess I didn't say that before. Acute means less than 90 degrees, right? If you couldn't remember that, you're like, that sounds familiar. What did that mean? Okay. So, if I try to write my equation for theta now, it's going to involve two pi, and then I'm going to have to take back like this part of it, right?
So 2 pi minus the
Yes.
whatever.
Alpha is what we called it, yes. So that's the equation that I'm going to write. Ugh, Mr. Kulik, so it's not always pi, not always 2 pi, it's not always added, sometimes subtract. Ugh, okay, thanks, great. So let's punch that through. So I have 2 pi minus cosine inverse, and then the absolute value of 0.32 is still 0.32. So my answer should be 503. I want to check if that's in between pi and 2 pi. It is. And that cosine of 503 is equal to 0.32, and it is, so we should feel finished here, right? Hannah.
Would it round to 503 or 504?
Oh, 504, thank you. Yeah, I just was going fast. Good point. Thank you. So again, we did alpha was cosine inverse, absolute value 0.32, and we got 504, and we checked that, you know, like 2 places. All right, yeah, let's sort out this how to write our equation for theta, yeah? All right. So I'm just gonna go over here and do that. So the things that the equation for theta is going to depend on is our labels on our x-axis. So I'm going to label this end x1 and this end x2. Remember before in the problem we did, this was pi and that was like 2 pi. That those n, whatever we have, are the label on our x-axis, which will depend on when we figure out what quadrants the answer's in, we'll have labeled that. Okay? Everybody okay what x1 and x2 are representing? Okay? Oops. So if we're in quadrant 1, we should do x1 plus alpha. If we're in quadrant 2, we're going to do x2 minus alpha. In quadrant 3, we're going to do x2 plus alpha. And in quadrant 4, we're going to do x1 minus alpha. And I think that works for both positives and negatives. Yeah, that should be good with the way we're doing it. Okay? What do you think you should do with this?
No card.
Yeah, this screams a note card to me, right? This screams, put me on a note card.
What is the x value represent again?
The what?
The x value represent again?
So it's the label on the x-axis in our picture that we draw in the beginning.
Oh, at the side, like the.
Yeah, yep, when we count around. We'll do we got another example still to go, so we'll see doing that and how this picture plays into the picture we drew in the beginning, but that's the plan, okay? All right, we ready to go on?
Yes.
Okay. So again, we're just taking one more example here. This is the last one I got planned for today. And then I'm going to hand you guys another sheet and let you guys work on these type of problems. Sound good? Great. So we start the same way. We observe that, hey, tangent is positive. So what quadrants are covered if tangent is positive? 1 and 3, yep, or A and T, or 3 and 1, or whatever order you want to say them in, as long as it's a 1 and a 3, or an A and a T. That sounds pretty good. Everybody so far so good? Okay. Now let's figure out what quadrants are covered by that interval from -3 pi over 2 to -1 pi over 2. Yes, Hannah?
Do you always start with 0?
I always am gonna start with 0. Now, the angles here on my interval are positive or negative? Negative. Which way do I have to go? Clockwise. So we're at -1/2. That's the start. -1, -3 pi over 2. So I would have covered those locations, right? Does everybody feel okay? So I'll draw our solution now. The terminal side of our solution lives in the third quadrant. And because we're dealing with negative angles, I am going clockwise here. Everybody feel good? So I'm going to go and write my equation for theta. So using what I just made, I live in the third quadrant, right? So it should be x2 plus theta. So my x2 is this label, which in my picture is -pi. Alpha is always calculated the same way. And now it's calculator time. Is this okay, everybody? We saw how I used the picture to write the equation for theta. No longer do I have to like reason it out. I can just like figure out what quadrant I'm in and then write my equation. As long as I did a good job labeling my picture in the beginning, I am good to go. Now you see why I've been bothering to write the labels on instead of just like counting along and... All right, let's get this up. All right, so we have -pi plus tan inverse 2.6. So I have -1.94 as my answer. We need to check our solution. If I type these two into my calculator, I get -4.71 and -1.57. Does -1.94 live between them? It does. And then my second part of my check is, does tan of -1.94 give me 2.6? So let's check that. And it does. What do I say?
It's correct.
I'm pretty positive I got it. Nick?
So if the question, or if the answer we found, for example, like -1.94 wasn't in between the two numbers we have in the equation or the problem, would we have to do the coterminal?
So, well, not necessarily. You should never have to do the coterminal thing for these problems. If your answer here doesn't lie between these, it's probably you've written this equation incorrectly. And if your answer doesn't check, you've probably done this part incorrectly. Like you forgot the absolute value or something.
I got it. Thank you.
Yeah, but you should not have to do coterminals with this. This is the beauty of this picture, is that you don't have to mess around with the coterminal piece anymore.
Okay. Thank you.
They were just cool, right? Yeah, give me that. Give me some of that.
Yeah.
All right. For you guys to work on. I'm done for today. So I'm going to give you guys some practice on this and some time to practice in class.
It's just me, like,
Yeah, very well.
I just wanna like understand
You just want to look at it here for a minute? Okay, if you got questions, holler at me.
I'm actually.
How is this feeling what we're doing right now?
I think I'm learning.
Okay.
Like with the paper's healthy. Like stack.
Yeah, I
Like just having a paper to look at?
I think around the same thing, why am I getting?
So
We actually,
if you do,
no, not, we should ask you.
so
Before you
instead
start,
you can,
We're not mad about it.
it's gonna take every decimal place the calculator's got stored. Oh, it still doesn't want to do that. Anyway, it's
You
fine.
gotta pay attention.
Okay.
It's supposed to. It's just like rounding.
Get your point, bro.
Stored it. Yeah.
Did you do the big lion?
Yes.
Would you mind if I grab the calculator?
Sure, go ahead.
Did you send me an email about turning in?
No, but I'm sure I will. If you sent it, I will get to it.
Okay.
I don't have any breaks today.
Okay.
Tough.
Oh.
Something like this.
I have like that one which, and I attached those to the email, but should I still?
I call you tonight.
It's fine. It is.
Wait, are you reading out?
What worksheet? I guess I have a question. I'm not sure what. How good were the photos? Yeah, as long as I can read them.
Like, I should have to call you tonight. Are you?
This one.
This was championship is really hard. Some people send me like pictures, like, I just can't.
Yeah.
It's not good enough, your photos not good enough, your pictures too bad.
Yeah.
To combine like, this is not good.
Yeah.
It's like you should take this from like across the room or something. Try to zoom in and just everything blurs out.
Yeah.
But I got that. Thanks, Mary.
This is they have like a party member, they have all their friends over. Yeah.
That's a hard to
Yes, by far. Especially on Monday.
It looked like he was getting ready.